Hello, hello. Okay, we have audio. Mhm. We have stream on YouTube as well. Amazing. And we have a working awesome keyboard today. Ah, So let's start with our CKA journey. Yeah, today let's finish this off. Yeah, set everything. 50. On. Let's begin. So in this scenario, you'll be able to practice changing the IP address for DNS within a Kubernetes cluster. Okay. Change the server cluster IP range that is given to each service. Okay. The hint is to modify the Kubernetes API server pod YAML. So, okay, let's check out the YAML first. The YAML files are saved in ATC Kubernetes manifests. Here we see server cluster IP range. Okay, do we have any services? Let's check that. Yeah. Oh, so it's probably /16 or something. And we have to change it to /12 because it's already at 1096. Okay. So yeah, here we see server cluster IP range is already this. Oh, okay. They want it to be 100, not 10. See, small difference. You have to keep an eye for those details. Okay, we get pods. Yeah, we wait for the Kube API server pod to be back up. Yeah. Okay, for that one. Okay, watch won't work for that. I can do this. Give cutter. Watch. Okay, yeah, we're back. But we're still getting the IP range in 10. Why is that? Can we change it to 100? Yep, we changed it. Let's see what the solution is. Change the API server command that hands out server addresses for the cluster IP. Yeah. This is what they changed. This is what we changed. Okay. Change the IP addresses associated. Change the IP address associated with the cluster's DNS service. Is the kube DNS service in the kube system namespace? Edit. So, oh my god, no. So if we edit the service, change the IP address associated. What? Do we have a numlock? Oh, okay. That's because we are in Vim. Export cube editor. I don't know. Is that just now? Okay. Yeah, I'm locked now. Yeah. So now we have changed the IP addresses. Is there anywhere else? Doesn't seem like it. Please add the object below will be ignored, and an empty file will abort the edit. Invalid value may not change once set. No valid changes was saved. I'm not sure how to do this. Let's see the solution. Yeah, we changed it to 100. The change will not be applied, but the YAML will be saved in temp directory. Okay. Okay. Okay, replace. And now if we check the service, it has the cluster IP of 100. So it seems like a service is also like a pod where you can't just change stuff in it. You have to delete it and get it back up. Okay. So what was the point of this? Let's see. In order to change how the new pods pick up their DNS info, change the kubelet config to use a cluster DNS of 10.6.10. Perform the change to the config YAML on the node where pods run. Then edit the kubelet config map in kubesystem namespace to use DNS. Reload the kubelet configuration without restarting the node. Okay. So first, it's always that, but sure. There are no other nodes. So systemctl status kubelet. We have a kubelet running, which is in this. This is the base. Yeah, this is where the config file is. Nano /var. Yeah. In order to change how new pods pick up their DNS information, change the kubelet config to use a cluster DNS. Okay, so what did we do first? Change the service cluster IP range that's given to each service to this. Okay. Change the IP address associated with cluster's DNS service. It's the kubedns service in the IP address associated with the cluster's DNS service. Okay, we changed the IP address that was given to the DNS service. And now we need to manually change the IP of the DNS that other nodes, or the nodes, the kubelet basically on the nodes, know about. So like the kubelet would be hitting 10.96.0.10, but now that the IP address of the DNS provider has changed, you have to change that in all the kubelets, which in this case is 1. And here we see and sudo system ctl restart kubelet. Then edit the kubelet config map in use DNS test. Reload. We changed config. There's a config map also. Kubelet config. Okay, edit cm kubelet config minus namespace kube system. We have to change it even here. So what is the okay? Reload the kubelet configuration. Okay, let's do that again, I guess. But why are we doing this? We changed the config.yaml. Okay, we changed this. We edited this. Yes. Apply the. Okay, let's see. Kube ADM kubelet update. Upgrading kube ADM. Do I have to do this? Restart the kubelet. Yeah, that's how you restart the kubelet though. Yes, but how do I check? Start a pod named netshoot which uses the image Nicola netshoot. Nicolaka netshoot. Ensure that the pod will stay in a running state. Get a shell to the pod and cat resolve.conf to check. Ensure. How do I ensure? Okay, let's see. Okay, run pod netshoot with the image netshoot. Okay, get pods. Creating. Let me just bring it at the top. Why is it taking so long to create a container? Damn. Use NSLookup tool to look up the DNS info for example.com. Okay. Running container error. Wow. Okay. Describe. Not container. Pod. What? Did I name it pod? Okay. Delete. Pod. Pod. Okay. What command did I give? Okay. Run. Okay. Run is for a pod. Sorry. Completed. And then crash back loop off. Okay, describe or netshoot successfully pulled back off, restarting failed. It showed completed, so all ready to start. Oh shit, what happened? State terminated. Why? Because it completed, so we have to give it a sleep command, I guess. Define a command and argument. Yes. How do I do that? How do I do that? Echo hello and sleep. Okay. Command in a shell. um uh, minus try run equals client minus YAML one YAML nano one dot YAML. Okay. We add an command to the container with Rx. Okay. Okay, replace minus f1 dot YAML. Okay. Did you replace it? No. Force container creating container running. Okay. Exec pods net shoot minus. Do I not have to give a container? Okay. Cat. Let's copy the path from here. And we see what the name servers are. And let's look up example.com. Okay. So you're served by this address. Let's look at the solution. Image, command, sleep on pieces. Okay. Bash. Perfect. You should remember this. We should remember this command. That's going to be helpful. Actually, what does that do? Okay, delete pod. Sure. I want to see the YAML that it makes. Like, does it give it two commands? Or I guess it makes that array thing. Array. Okay. Anyway, come on. Oh, who cares? I just want to check what this does. Try run equals client minus YAML. Yeah, so it creates that array of commands. Okay. So we should remember this. That's a good imperative command to remember. This is actually a very good series. Like, it's a little outdated at some point, like upgrading Kubernetes. But this is a good way to learn for the CKA exam. In this scenario, you will be able to practice with reaching a service from another pod via DNS in Kubernetes. Okay. I just want to check something. DNS for services and pods. Yeah. Namespace dot service dot local dot cluster. Okay. That's how it's usually. Anyway. Create a deployment called Apache that uses create deployment called Apache with image as httpd minus try run equals client minus YAML 1d dot YAML nano 1d. Let's see. Okay. Okay. Apply minus f 1d dot YAML. Okay. Get pods. Container creating. Fine. I'll create it. Deploy Apache. Create a service named Apache service created from the Apache deployment. Okay. Okay. Expose deployment Apache Apache service. But at what port? That's it. How do you do that expose thing? Oh, that's not what I meant. Commands. Command line tool. Kubectl commands. We have expose over here. Kubectl expose pod. Okay, that's not what I meant. Create a service name. Okay, create service. Create service. That's it. Cluster IP. About SVC. That's it. About you need a port. Cluster IP. Let's just give it a port. TCP port name. I don't know what it exposed. Yeah, that's what I was doing. But then I checked expose. You can do it for deployment, but you need a port. Okay. Okay. Sorry about that. HTTPD, it should have been obvious. It's port 80. But I thought they wanted something else. Anyway, this is the command kubectl expose deployment Apache as we are doing. Okay, you have to specify a name with expose for the service and a port number. Create a pod named netshoot that uses the image. Execute into the pod and verify that you can reach the service by its name, Apache service. Okay. Okay. We know that netshoot doesn't run well. Okay. Run. Wait, what? Something else was copied. Oh, let's just copy this. Copied. Okay, run netshoot with the image and command sleep. 3600. Okay, and let's exit into it. Okay, netshoot bash container not found. Okay, get pods. Go to still creating. Okay, perfect. That what? I guess we have to give minus ID. Giving bash. Yeah. So you can try pinging it. Okay. But we are verified that you can breach the service by its name. But we are not able to. Okay. Get services. Okay. Okay, get services. We have the Apache service running on port 80. Will it only listen on port 80? Maybe. Curl Apache service. Yes, it works. That will only listen on port 80. That's why ping won't work in this case. Solution. Kubectl will run netshoot. Okay. Did wget. Hold on. So what we've learned up till now, like from this, is like the cluster IP, the range of IP addresses that are given out by the cluster to the containers and the pods and the services is in the Kube API server configuration. And if you're changing the DNS IP address, then you have to make changes to the kubelet configuration to point at the correct IP address or the new IP address of the DNS. And the way to reload is you do the daemon thing first and then reload. Yeah, daemon reload and then restart the service. Okay. Create ingress resource. Let's do this. Yeah. In this scenario, you will be able to practice creating an ingress resource on Kubernetes. Enjoy. Definitely. Create an ingress resource that will allow you to resolve the domain name hello.com to the service name Apache service over port 80, and during the exam you will be able to access the docs, search for the word ingress within the docs for YAML that you can copy paste from it. Oh wow. I guess they've made it the other way around. I don't know. What do you think we've been doing up till now? Anyway. Massive thanks to the person who's made these labs for us. And one thing, one.yaml. That's okay. Okay. So create an ingress resource that will allow you to resolve the domain name hello.com. To this minimal ingress. Ingress rule. We want API group. That's not what we want. But nowhere are we mentioning host hello.com over here. So we search for host. Yeah, this is what we want. Rules for host. Where hello.com over port 80. Hmm. Do we need these? Let's see. HTTP paths. You just remove these two. The path. It should directly go to the backend. Yeah. Service name. What service is it? Apache service. So let's see. Let me explain what's happening here. So we are creating an ingress. Let's name it ingress Apache. So what rules we're giving is when something is coming over hello.com, and since it's a domain name, can we give non-HTTP paths? Does it have to be HTTP? I wonder. Okay, yeah, it is assumed since it's a Nginx, it's a HTTP proxy. So yeah, it will be an HTTP request. So when the HTTP, we also have the ability to resolve different paths like hello.com/1 to something else, or hello.com login to something, hello.com/sign up to another page. Like if you have microservices, then you will have maybe a login microservice and a sign up microservice that is different. So it would go to different pods or services actually, which are associated with those pods. So here you can mention those paths which we deleted. We'll see whether we require them or not. And in the backend, that path should resolve to the service, which is named Apache service. And on the Apache service, it should go on port number 80. So let's see if we can create this. Apply -f one.yaml. Invalid. You need a path type. Okay, we need a path type, but we need a path is what I want to check. Path type. I guess if you're giving it a path type, you need a path also, but let's see. Must have an absolute path. What if I don't have a path? What if that is what it is? Empty path? Must be an absolute path. I guess then it's just slash, as they gave. They didn't. Path, all paths. This is how it works. So you have to give a slash. Wait, why is this twice? Okay, this and this means the same thing as what they want to tell us. This does not match this. You have to be very, when you're doing exact, you have to be very careful. Okay, good to know. So that's what we did. Slash Apache service hello.com spec minimal ingress. That's what they took it from. Yeah. Ingress class name. What did we give? Did not give one. Let's see. That's it. We check And eh, expose. How do I do that? How do I point? It doesn't have an address, right? It is on the control plane itself. Provide this internal IP. If I call this, there is no connection to port 80. I want to give it a node port. Ingress. Wait. This is the node. We don't have an address. How do we attach it to the? First, we have to give it a class. Okay, edit ingress. Namespace default, that is fine. Where did I get that? They have not. But here, have they? Ingress class name. Okay. Types of ingress, DNS, load balancing, alternatives. Ingress rules, okay. Ingress class. Different controllers, often with different configuration. Each ingress should specify a class as a reference to an ingress class resource that contains additional configuration, including the name of the controller that should implement the class. Oh, do we have an ingress class? Sorry. Okay, get ingress class. Oh, resources found. So we need an ingress class. Not a particular actually, okay, we don't have any. Ingress engine can be configured with the flag what without flag. It is recommended though to specify. Okay. Pod restart policy. Okay. In this scenario, we'll learn how to run a pod and change the restart policy. Bruh. Nice. Use kubectl to create a busybox that uses the busybox image. Okay, run busybox minus image busybox. We've done that. Determine why the pod is not running. Okay, get pods. Okay, describe pod busybox. Successfully pulled back off. Terminated. Reason it was completed. Okay. Last hit terminated. Reason it was completed. Change the restart policy to prevent the pod from automatically restarting. Okay. So You know that. Let's see. Okay, edit pod. Oh man. Busy box. It should be in the pod spec. And restart policy. What are the restart policy? Uh, no pods. Yeah, restart policy, container restart policy, always on failure. Okay, we change it to on failure. That makes more sense. Insert mode. Escape. Right quit. Okay. This is what we have to replace it with. -f force. Okay, get pods completed. Restart policy never. Change this from always to never. On failure makes sense. Okay. And here we have the last one, persistent volume. Create persistent volumes and persistent volume claims in Kubernetes. That's nice. So let's see. PV. Persistent volumes. This is the one. And this one. So there are tasks. That is what's more important than persistent volumes. Nice. Let's increase the font. Yeah, there we go. In this scenario, you'll create a persistent volume, a persistent volume claim, and a pod to use the volume in Kubernetes. Okay. Create a persistent volume named PV volume that has the following specifications. A delete persistent volume claim policy. Let's see. Use a persistent volume. First, we'll create a persistent volume. Copy this. Nano pv.yaml. Yeah. Name. You want the name to be PV volume. Okay. Easy. PV volume. Delete persistent volume claim policy. Persist reclaim policy. Is that it? Yeah, where do I get the YAML? Give me the YAML. There's no YAML on this page. It's not useful for me. Persistent volume. Fine. This is the one, but provisioning. What options do I have? It doesn't show anything. This is for a pod. Wait, if there. Oh my god. Okay. So don't ever search for that. Find persistent volume claim, persistent volume, storage class. Persistent volume reclaim policy. Okay, this is the one we want. Okay, let's just take this spec. To the very bottom. Delete persistent volume reclaim policy. Uses the storage class name local path, storage class name local path. References a claim named reclaim in the default Use host path one. Mount data, this is right. Has a capacity of 1 gig. Access mode read write once. References a claim named in the default namespace. We also need claim name. Delete the claim ref entry. What is this? Okay. You do it for a persistent volume, right? And no. Let's do it there itself. This doesn't matter. It will be in the default namespace. PV claim. So we gave it a local path, claim ref, namespace default. That's something we didn't give. Should we? Let's give it up anyway. Like I mentioned many times before. Better to be specific than sorry. Namespace default. We have a host path, mount data, a capacity of 1 gig, access mode read write once. That's it. And k apply minus f pv.yaml. Persistent volume created, k get pv. That's okay. That's just one. Create a persistent volume claim that has the following specification. Yeah, that's it. Reserving a person. The control plane can bind to matching person. The control plane can bind persistent volume claims to matching persistent volumes in the cluster. However, if you want a PVC to bind to a specific PV, you need to pre-bind them by specifying a persistent volume in the persistent volume claim. Okay, I'll call this PV and PVC. By specifying a PV in a PVC, you declare a binding between that specific PV and PVC. If the PV exists and has not resolved PVC through its claim ref field, then the PV and the PVC has not resolved PVC through its claim ref. The binding happens regardless of some volume matching criteria, including node affinity. The control plane still checks that storage class, access mode, and requested storage sizes are valid. So first you make a persistent volume, and then you make a persistent volume claim. That's how I've always known it. Let's see. This method does not guarantee any binding privileges to the PV. If other PVCs could use the PV that you specify, you first need to reserve that storage volume. Specify the relevant PVC in the claim ref field of so that other PVCs cannot bind to it. Okay, yeah, that makes sense. Like you're basically reserving this for this PV for a PVC named foo PVC. It's like this PVC is my only one, is what the PV would say, and it'll just wait till the right one comes along. But okay, so we created a PV. Now we have to create a PVC. Let's get it from here. Create a PVC. Nano PVC dot YAML. Name PVC claim. uses the storage class named local path. Access mode is read write once. Requests 1 gig. Once you've created the PVC, list all the PVC claims in the cluster. Okay, apply minus F PVC YAML and K get PVC. Pending. Will it always be? PVC claim, that's what I call it. Okay. It's still pending. Wow, okay. I thought it would bind. Now that we have created the persistent volume, PV, and the PVC resources in Kubernetes, let's create a pod that can use the volume. Create a pod named PV pod that uses the image nginx with a volume named PV storage. Mount the volume inside the container at this path and specify the PV by its name. After you've created the pod, list all the pods in the namespace. Okay. Are you sure it's not binding? Okay. Okay, let's see. Mounting the same persistent volume into create a pod. What do you want? Nano pod dot YAML. Create a pod named PV pod that uses the image nginx. Yes. With a volume named PV storage. Volume PV storage. Persistent volume claim. Mount the volume inside the container at fine container. We don't need ports and stuff. Volume mounts, user share engineering, PVC by its name. Yes. PVC claim. PV claim? Okay. PVC claim. That's not what we wanted to do. Did I read it wrong? Okay. Replace minus F PVC.yaml. PVC claim. Yeah. Yes, I wasn't wrong. But I think they want to teach something. Or in the solution. PVC PV claim, I think. Oh, this is a typo. Okay. I'm glad we sorted that out, and I'm glad things are working the way they should be. PV claim got bound. Okay. Nano pod.yaml. This would be PV claim. User mount task PV storage. name. No, this has to be same. Volumes, PV storage. Okay, apply myself part. If containers, and we have volumes. Same thing. PV storage, PV storage. Now that up, hey, it's the same thing, man. Running the same persistent volume in two places. That's what we're doing. Okay, now that our pod is created and it's using the volume that we provisioned, how do we know? Okay, get pods. Okay, get pods minus a white. No. Okay, get pods. Describe pods. Pod. Storage, volumes, PV storage, PV claim. Okay. Now that a pod is created and it's using the volumes that we provisioned, let's write some data to the volume and see if the data persists beyond the life of the pod. We'll start by getting a shell to the container in the PV pod and perform the following command. I don't know. Let's just copy it. Okay. K exec minus IT PV pod bash paste event not found. What do you mean event not found? I think this should go in single quotes. Yep, single quotes is raw text. Okay, once you've written that index.html file to the volume, go ahead and delete the pod. Okay, delete pod PV pod. Start a new pod with the same specification but name it PV pod 2 instead of PV pod. Okay, pod, name it PV pod 2, and k apply minus f pod.yaml. Okay, get pods. Sorry, we have pod 2, and let's read this file. Oh yay! If it is, that means that our data persisted beyond the life of a pod. Life of a pod. That would be such a great movie. Okay, yeah, we did all this stuff. Wait. I'm running the same person in two places. Okay. Within the same pod, you can have it at two places. That's nice. But then, yeah, change in one would change the other two. Yay! We finally completed this. Woohoo! Yeah. So we'll come back maybe if required. Once I don't know, I'm just curious. Open feature. Oh, I am so sorry for the sudden light mode. He's the creator of Killer Shell CKA simulator and provides additional scenarios here to help master that exam. Okay. CKA topics. How can you solve them all? Yes, we can. Maybe. If not, we'll take some help. Log reader 2. That's a lot. But we take it one step at a time. These are most commonly asked questions on architecture, installation, and maintenance. Yes, that's nice. We need practice. Useful resource, keep cheat sheet. Oh, okay. For this question, please set this context in exam. Different cluster name. Okay. Pod is running. Save all info and errors. Pod logs in podlogs.txt. Okay. Okay. Logs. Pod / alpine log reader container. Let's see. All info and log. Oh, I did paste that. Save it to pod logs. Check. Yay, we have checks. I like that. Thank you, Mr. It was right here. Oh. Come on. At the back button. Yeah. Thank you, Mr. Such an HR. LinkedIn. Not found. That's sad. Profile. Okay. Ghost traffic. Solution. Okay. Man, you're amazing. Thank you. Thank you so much. Log reader 1. Let's do this. Okay. For this question, please set the context. Okay. Is running all pod logs. Is it any different? Okay. Logs. Log pod. Container. Wait. Okay, get pods. Okay. Logs. Log reader pod. Container. Pod all logs. Yeah. Check. We saw this. Some. Why would there be two of the same kind? Architecture installation. Find the node. Do we have weightage also? What he's mentioned? Oh, my bad. But yeah, let's just zoom in and then zoom in even more. Yeah. Find the node that consumes the most memory. Wait. Architecture installation. Yeah, that's the one. Save all error log pods only. What did we do? Save all info pods. Okay. You do this. And then a logs log container. That was the one where you have to save all. Save all pod logs. I think there's some sort of mistake. Sadly. A logs. But yeah, if we have to just put in the error ones, what we can do is check for error. And you have only the error ones. Let's see. Does the check work? Yeah. Nice. They've put in a good check. Does the check work? I guess it would be somewhere ahead. Oh, there are multiple log readers. Pod logs, pod logs. Okay, nice. Architecture and maintenance. Where does it start from? I guess. Okay. Anyway, we won't get questions in a, order that we want, in some systematic order. It could be anything. So let's do this. For this question, please set the context. Okay. etcd control plane pod is running in kube system environment. Take backup and store it in the file. etcd backup is stored at this on the control plane node for data to use. Just restore it on the control plane node itself, and also restore console output, store it in restore.txt. SSH control plane. Okay. Okay. So etcd backup. We don't need this stuff for now. Okay. Backing up. This is what we want. Sorry. Yeah. Endpoint backup dot command. Yeah. CKA get pods minus a. So since we have a kube system, that means it's running with kubeadm. So just cat. Sorry. etc kubernetes manifests etcd, and this is the URL. That is what we'll take. Let's also check out kube API server. etcd server is I'd go with this. Yeah, just copy this. No backup.command. We have this correctly set. CA cert everything etcd. I'll just copy this and then okay. Yes, sir. The cert file. The key. We need to add that forward slash and actually let's do that. Slash slash. Oh, we missed. Wait, thank God we did that. And save location opt. Okay. And backup. We use this command. Snapshot saved. Amazing. No. Okay. Sorry. Ooh, lot of data. Okay. Sorry. etcd backup is stored at the path this on the control plane node for use this. Okay. So how do you restore backing up? Snapshot restoring. This is what you do. No, backup. Oh no. etcddl. Lightning strikes every time. Data there. Snapshot. And we have to save it from. Oops. We have it over there. Yeah, we used that. We need to save it from here. Yep. Restore it on and restore output. Store it and restore.txt. Okay. Cat backup. This is what we have to run and store it and restore.txt. Cat restore.txt. Huh? Wait, what? Default etcd. Yeah. Restoring. Stop all APIs. Restore state. Restart all APIs. If any API servers are running, you should not attempt to restore instances. Instead, follow these steps to restore etcd. Stop all API server instances. Restore state in all etcd instances. Restart all API server instances. Yeah, we have to change API server, right? Sorry. Kubernetes manifest. Kube API server. Sorry, etcd. You only have to change it here. Volumes. So while etcd is where you change it. Okay, control U. Just keep this for future reference. I want to do that also. That's also remaining. Yeah, this is down. And at the same time, I want to do this. But it did not. And EDC. DC. No. EDC. Export. ETCD CTL H. Restore, right? Restore minus H. Minus help. Unknown command. Snapshot restore. Okay. Snapshot restore. I think minus W is what we have to give. Man, that's difficult to read. Let's delete this. And do this again. It's still empty. What the hell? Can we like check what it does? Right out. Set the output format. Fails. Okay. That's different. Global options are free. Options help. I don't understand why that isn't working. Is this interfering with anything? That's true. I really feel like doing that now. Is this error? I'm not sure. Restore is still empty. I check. Validation failed. We don't know which part of the validation failed, but that's fine. I'll just take all this data and cheat. Can you check now? Yay! I don't know how to write it. Okay. But that's, yeah, we wouldn't know there. So, like in the main exam, we wouldn't know. We won't have the option to check also. So, there are, for this question, please, okay. etcd control plane pod is running in kube system environment. Take backup and restore it. And also store backup console output. The same thing. Why is this different? Do the whole thing again now. This isn't fun anymore. txt. Okay. More slash etc Kubernetes manifest kube bi server. This is everything etcd. So let's just copy it. And okay, yeah. Nano command. We paste it here. The endpoint is correct. Let's see a file. Third file. E file. Okay. PA file. Third file. And key file. And the backup location should be db. Cat command. We just run this. Okay. We miss a slash there. Validation failed. Yeah, to do this now. etcd restore slash root slash etcd restore, and this would be this deprecated and stuff. Nano restore.txt. Nano backup.txt. Oh, okay. Does it look for everything? I don't think so, because timestamps would be different. I don't know how it's checking for it. I want to see what it's checking for. Not that either. RM backup. CP restore to backup.txt. Does this pass the check? Wait, am I not in the... I am in the control plane, right? Yeah, I am. I have always been in the control plane. Okay, let's restore it. Nano etcd Kubernetes manifest kube API server X. This is what I need. And at the very bottom, volumes, yes. No, sorry, not in the kube API. etcd. Here, instead of varlib, etcd, we do /root etc. Check now. Okay, get pods. I did change the context also. What is the issue? I don't know. It's updating, I know that. And also store backup console. We need it from when we backed it up. This thing. I'm pretty sure you can just get away with that. Okay. It checks for some other things, but I don't think it's check because it can't check for the because there are different timestamps. TS. Okay. What if I delete a lot of this? Check again. See? So I guess what it is checking is for. But there should be 1, 2, 3, 4, 5, 6 lines. 1, 2, 3, 4, 6. It does have a security because there are checks everywhere. So you need to understand what are they checking for. Come on, there's only 5, man. Okay, no, there were 6. Probably they're passing the JSON. What if I do this? Successful. Oh, maybe not. But yeah, it is the other way around. etcd backup and then restore. Secret 1. Podlogs 1. That's how you have to do it. Okay, secret. We set the context, create a secret named database app secret in the default namespace using the contents of the file database. Base. Okay. Okay. Create secret called database app secret from from okay. In the default namespace. Okay. As ASCII crash cluster disable insecure kube config namespace password profile output server token secret, right? I gave it a name. Create. What is secret generic? Create a secret based on file directory or create a secret using sub specified. Okay. Generic. Okay. You have to give generic first. Generic database from file here. From file data this. Get secret. Get describe secret database. Nice. Check. Yay. Next one, secret one. Yeah. Set the context. Decode the contents of the existing secret name database in the database namespace. Okay. Describe secrets minus and this. Name this. And save the decoded content into a file located there. Okay. I guess we'll have to edit it. DB password. Oh, sorry. Q. No writing. Add to override. Okay. Q. Yeah, we need to decode this. Base 64 minus T. Secret. Okay. And we want it in decoded.txt. Can decoded secret. Yep. Check. Amazing. Wait. No, don't start. Okay, this the only cluster upgrade one around. All right. Well, there's a lot of stuff. Let's zoom in. 150. That should be enough. Yeah, I'll just open images in new tab if required. For this question, please set the context. Okay. Upgrade control plane node kubeadm cluster kubelet to next version. If current version is this, then upgrade is this kubeadm version minus o YAML. The current version is 1.30. Okay. Oh, gate version is what you look at. Okay. 1.30.1. We have to go to 1.30.2 after upgrade. Similarly, verify upgradation for current version. Okay. Okay, that's the next. Let's just. Okay. You don't. Okay. KubeADM plan. Upgrade plan. v130.4. Okay. Sudo apt update and sudo apt install KubeADM equal to 1. I don't think we give a v. I don't need this. Sudo stopped it. Apt search KubeADM. That's the one they have. I have to update it there. Yep. Let's check version now. 130.4. Okay. Now KubeADM upgrade plan and upgrade KubeADM. Upgrading KubeADM clusters. Yes. Determine which version. Upgrading control plane. Yep. We did this. Yeah, that's where we are going. Sudo KubeADM apply 30.4. Are you sure you want to proceed? Yes. Wait, no. Can I do one? Yes. That is what I want. Like, even if KubeADM version is going up till 4, we can make our cluster go up till 1. And it's always a good practice to install in the steps instead of skipping versions and directly going to another bigger version, because it can cause issues. So sometimes the developers, they do give methods, or some, they, if they make major changes, they do give us some tools sometimes to migrate easily. Sometimes, not all developers, like usually big organizations, but yeah. So it's better to look at the change logs and then upgrade one version at a time. So this thing can take up to 5 minutes. But yeah, this is good practice. We need to do this. Didn't you just say it would take up to 5 minutes? Oh. Yeah. So complete control plane. Do we have more nodes? Or I think it's a control plane node. That's what they want to say. Upgrading call cube control plane. Use a version to upgrade. Yeah, no. Manually upgrade your CNI provider. For other control plane nodes, same as the first control plane node, but use. Okay. Since one is upgraded to a specific version, now you just have to bring others to that same version, so you don't need to specify a version. For other control plane nodes, that means it's in a high availability architecture, or like multiple control plane nodes, multi-master architecture, you could say. Yeah. Let's take a water break. Wow. Okay. Amazing. A cluster. Your cluster was upgraded to version 1.30.1. Now, we don't need to do anything, right? Let's just check. Kubadium version. YAML. It's at version 4. And Kubadium upgrade plan. Yeah. We are at this version. And do we have other nodes? Oh, we have another node. Wait, what? Why is this? Oh. For the first control plane node. Didn't we upgrade our control plane? Control plane should be at version 1.30.1, right? Verify the status of the cluster. Is it that after I do that, only then will it show? Let's see. Drained. That's the search. Node 01. Where's the game? Kubelet and kube. Okay. Just get it to the latest version. Under 30.4. Okay. A get kubelet version now. Minus H. Whoa. Minus we. Command failed to pass. Needs an argument v in minus v. Unknown command version. Okay. Anyway. Cube cuttle. We have to do this in the control plane. Node 01 uncordoned. Create work nodes. One node at a time. Verify the status of the cluster. Why does it not show here? Medium. When that is the current. Is it because cube cuttle version? Is that? Upgrading cube A. Cleaning the package repo. We don't need that. Determine which version to upgrade to. Shouldn't take this long, man. Okay. Cubadium version is 130.4. Cubadium plan. The command checks that your cluster can be upgraded and fetches the versions you can upgrade to. It also shows a table with the component config. Choose a version to upgrade to. 30.1. Please proceed with upgrading the kubelets if you haven't. Don't tell me it'll take 5 minutes. Cluster was upgraded. Sudo apt install kubelet. Still nothing. Yeah, so kubelet upgrade. Do I need to restart kubelet? Yeah. Yep. But I did that on SH node 1. We did this. It wouldn't work. Did it work? Okay. Yeah, just do your thing. Yeah, it's already the newest version. Okay. Okay, get notes. I guess it doesn't. Okay. Scenarios. Service filter. Set the context. You have a script named service filter. Update the script to include a command that filters and displays the value of target port of a service named this using JSON path only. I don't use JSON paths. I don't know how to do that. Items.0. Oh, उसके first item. Okay, let's see. Nano svc svc dot filter. Oh wow, you have a script name. Update the script to include a command that filters and displays the value of target port of a service named this using JSON path only. We get svc this, and I just need target port. Okay, minus oi minus oi JSON spec target port. Okay, do we have that? JQ. Ah, let's see what does this do. Here's the current one. Then dot spec dot ports dot target port. Dot spec dot ports dot. Let's do this. But it is an array. So I'm assuming start dot target port target capital P. We don't need the JQ part. Okay, so this is what we need. Nano svc this sh svc key not found. We can't give k, we have to give kubectl. Had we done it with bash, I guess it would have worked, but that's fine. Give it kubectl. It should be the format kubectl get SAC, or it should be in the format kubectl get service. Yeah. Validation failure. No worries. What if we give it like this? Nothing. What do I give it? 0. Do I have to give it 0 then? What do you guys think? Check. Validation failed. You gotta get SVC. That's what I have, right? Oh, can I not give a name? Is that what they think? Dot items. That is service. Oh my god. I cannot do this. I have to do this. 6443. Okay. Okay. Get SVC. Smart. So I have to do items 1. Spec. Nano SVC. And remove this. What the hell? Is this what you want? Let's just check the solutions. Thank God there are solutions, but I don't know. Control F SVC. Yeah, update the script. Man, that's what I did. I just used at, which means, oh, I don't like it. So see, according to the docs, the current object, same input, and install. Fine. At least you learned. What? Of course. What's the name? Redis service. Is that the only one? Check that. No, there are 2. Let's go with the one on the right. Okay, set the context. You have a service account named group1sa, a cluster role named group1 role CKA, and a cluster role binding named this. Your task is to update the permissions for the group1sa service account so that it can only create, get, and list the deployments and no other resources in the cluster. Okay. Cube editor equals nano export a get SA. That is a group SA. Okay. A get role. You have a cluster role. Cluster role. Grab group. A get cluster role binding Oh my god. Grep group. Yep, we have that too. It asks us to update the permissions on the group 1 SA service account. Okay. Okay, edit SA. No, so we have to change the role. Okay, edit cluster role, which is this. Actually, instead of edit, okay, get minus OYAML cluster role dot YAML. I don't know, CR. Cluster role, create cluster role. Yes. Verb equals get and list, get and list, resource deployments, API groups. What are the API groups? Apps, I'm not sure of that. I think this is correct. Okay, replace minus FCR minus force. Replaced. Can you please? Oh, we didn't give create. Sorry. Create, replace, and check. And that's a valid check. Yay. I'm so happy. Create a service account name account, a cluster role, and a cluster role binding. Update the permissions of the service account so that it can get the pods only in the default namespace. Okay. Okay. Create SA. Okay. Create cluster role. Verb get resource pods. Okay, get cluster role minus YAML API groups. What is this API groups thing? API. Create a cluster role named foo. Replica set.apps. Let's ask ChatGPT what is the difference. What is the difference between these two commands? kubectl create role. Resource name specify. Allow the user from get resource name pods. The difference between two commands lies in the way the resources are specified. Both commands are creating cluster role named foo, but in summary, while both targets the replica sets resource type, specifying the okay. Oh, my bad. I'll just zoom in. Woo, 150. Yeah. In summary, while both commands ultimately target the replica set resource type, specifying the API groups explicitly in the first command removes any ambiguity and ensures that the permissions are applied to the replica sets in the app's API group. The second command might work correctly in most cases because RS typically maps to replica sets in the apps API group, but it lacks explicitness and could potentially lead to confusion or unexpected behavior if there are other resources types with the same short name in different API groups. Okay, so places where there can be a conflict is where there will be a conflict. Okay, so I guess it would just give an error or something. Anyway, we create a role binding now. Okay, create cluster role binding. Cluster role. Wait, let me just give it its name. Cluster role and wait. Cluster role binding. User group. No, we can't just give user. There are other ways too. Let's see. I think it's not. It might not be in the command part of it, but cluster role binding. Okay. Any YAML role cluster role binding cluster role binding subjects. Yes, service account is what I wanted. Service account is app account. Thank you. Default. You can get pods only in the default namespace. Doesn't this? But it's a cluster role. So, okay. Get cluster role minus OYAML. Should I give it default pods or something? Oh yeah, you specify namespace. Where is the namespace? I don't think this is correct. What? Yeah, so it's account name the cluster role. Yeah, that's what we did. It is. But since it's a cluster. Oh. Mm. If I created the service account in a different namespace, then it would be a problem. Let's see. We're here to learn. We're here to learn. Okay, yeah, let's just do this. A cluster role. Okay, create cluster role. This verb get resource paths. Okay, create cluster role finding. Name this role. Oh no, cluster role. Yes, this service account. This. That is what sets it. Got it. The setting of the service account in the namespace is what decides what resources it can access. What resource? How many are we done with? Oh, this has been a 2 hour long stream. Okay, what is this fun? Find the pod that consumes the most CPU in all namespace, including cube system in all cluster. Currently, we have single cluster. Then store the result in the high CPDX with the following format: pods name.namespace. Okay. A top. There was one. The CPU. Okay. Run. App management, working with apps, cluster management, API version, certificate settings and usage, version, completion, API resources. What was the command? Not certified. Cluster info. Uncon, no. There was an option I remember. Okay, yeah. We should go there. I'm sorry. Quick reference. Keep Carter. Which one's the same thing? It is, and yet it is not. Oh, this is in different language, I guess. Yeah. Control F, CPU. Oh, interacting with node resource type. Uh-oh. K-top. Yeah. Find the put that on. Move CPU and all namespaces. Mod by CPU. That's what I gave. Pod name and namespace. -O wide. Any more output? Field selector. All namespaces. Okay. Was there not a top here? Control F top. Working with apps? Okay. Top, no name. Pod namespace, all name. Two metrics of a given pod and its containers. Pods defined by label. Field selector, selector field. The server only supports a limited number of field queries per type. No headers. If present, print output without headers. Okay. That's what we want, right? A. This. Pod name, comma namespace. I guess that would be a better way to do it. Just, yeah, don't think too much on the exam, I guess, because you don't have time. Yeah, okay. Like how I would format it and get it, don't do that. Did I just hit restart? Okay, thank God. How many are we done with? Four. Okay, let's get done with 12, like 13 actually. Yeah, create a Kubernetes pod configuration to facilitate real-time monitoring of a log file. Specifically, you need to set up a pod named Alpine pod that runs on Alpine Linux container requirements. Name of the pod. Okay. Run this image, this try run equals client -o YAML pod dot YAML nano container image, container name should be Alpine container. Configure the container to execute tail. Yeah, we know this. Command. We don't know this. Command. Come on. Oh, no, no, no. Yes. Is it command? It's command. This has different meaning. I don't think I'm doing it right. Let's just read this. You have a Kubernetes cluster and define you can define a command and arguments for the containers that run it. To define a command, include the command field. To define arguments, include the arguments field. The command and the arguments that you define file override the default. If you define arguments but do not define a command, the default command is used with your new arguments. Okay, that's why you have arguments. Okay. Using command. Okay. How about the arg set? Same, right? Fail slash bin slash sh. Yep. I am sure. To continuously monitor and display the contents of log. Set up a volume named volume pod. Configure pod to use volume for storage. Volume. Set up a volume that maps to a config map. Volume config volume. It should be like the volume bar. This log config map already available. Ensure the pod has log.txt and log.data. Okay, we're uploading the log.data. Is it? Okay, edit cm log. Create a config map. Control F. Kind is pod. Yes. env. No. env. And config map data to a volume. Yep. Volume map. Provide the name of the config map. Want name. Map. No, we need to do it here. Oh my god. Control X. No. Volumes. Name is fine. We don't need this. Instead, we need this. Map. Let my volume name this. Okay. On path slash config, I guess. Oh, restart policy. Sorry. Okay. Nano pod restart policy. I have to be more thorough with what I do, but it's like replace -f pod. Check. Validation failed. Execute using args with using command. Maybe because of that. What is it that you're looking for? Yes. Command benefit -c args. Okay, we can give args like that. Volume mount name config map mount path slash config map. No, so that is all is the difference. Let's just take this out and bring it here. Need this. Describe pod. Pod. What is the command that you're running? Args. It had the -c in the beginning. Yeah. V1 pod tables. No one cares. Name pod. Okay. Pack containers. Image alpine. Container and images alpine latest. Command has been a search. Args. I've given them config.log.txt. Yes. Volume mounts. Config volume. Mount path is config. Volumes. Config volume. Config map. Log config map. Restart policy is never. Then what is the problem now? it now. Mm, okay, describe pod. Does it really make a difference? Strange. This is the last one. Pod logs for today. Been a 2.5 hour stream already. I don't want to elongate it much. That's the context. Product pod is running. When you access logs of this pod, it displays the output MITVS code. Okay. Okay. Logs pod product MITVS code. Please update the pod definition file to utilize an environment variable with the value Sony TVs. And recreate this pod with the modified. Okay. Get pod product minus o YAML pod.yaml. I don't know what it runs, so I want to check what command it is running. Oh, yeah, please update the pod definition file to utilize an environment variable value Sony TV is good. Then recreate this pod with modified configuration. Like YouTube brand maybe, and env define environment maybe for a container. Yep. Env name value. This goes in the container spec. Perfect. So like right after the command we can do this. Paste value Sony, and this should be brand. A replace minus f pod force. Okay. Why is it taking so long? Yes. Yes, a 3-minute wait. Okay, delete pod. There are no resources. Okay, apply minus f pod.yaml. Product created. Okay, logs product brand TV is good. That's raw. That is the issue. A delete pod product. A apply minus f pod.yaml. Try again. Okay. Let's delete. Deleted, right? Okay, get pods. No. Yeah. Apply. Created. Okay. Logs. Product. Kubernetes is good. Yay. What was the solution they gave? Sony. Sony. Edit pod. Echo. This will update the pod template. Just push it. To utilize an environment variable with the value Sony. Where is it that you're using an environment variable over here? Cheaters. That's what I did. It was slow. Okay. Yeah, there it says we should have used for fast update, we should use the force flag, but even with the force flag it was slow. So yeah, I do realize I don't speak a lot on stream, which I should do because I'm on stream. Yeah, I guess I'll learn with time. So yeah, that's it for today. Thank you for joining in if you're watching this in the future. Yeah. Thank you and bye-bye.